Hey guys, welcome to the channel IF 4.0. This is Ajay.
This is part 2 of the source. We have completed all the aspects above source in the previous video part 1, and in the part 2 we will be seeing remaining properties of the source object. So we have seen till percentage in the last part. So till percentage we have seen. So we will validate this whether it is working correctly. So 60% of the parts will come with a cycle time of 5 minutes and 40% of the parts will come with a cycle time of 10 minutes. So I have prepared one small model putting 3 queues into it, and I have connected the generator to it. So the parts will be generated by percentage method, and the 40% part will come here, which are going to have a cycle time of 10 minutes, and 60% part will come here, which are having 5 cycle time. So if we run and check, so when the parts are run here, you can see in the certain runtime 80 parts are came out, which has 40% rule, and 126 parts has 60% rule. So when we calculated that 80 parts out of 205, it comes approximately up to 39%, that is 40% near to. So the by percent rule has been validated, that the 40% part has came with a 10 cycle time and 60% part has come with a 5 cycle time. After checking out by percent method, we will look into periodic rates method. So in periodic rates, firstly comes as hourly rates repeating weekly. So the values here indicate the number of parts required in particular hour on the particular weekday. So our model begins on 21st of, that is Thursday, July 2022 at 8 AM. So what we are going to do is on Thursday 8 to 9 we require 40 parts. Then from 9 to 10 I require say 60 parts, and 10 to 11 I require 100 parts. We'll validate this. I will reset this, and the part will come from generator to Q1, and then it will come to this queue. So what we are going to do is we are going to run the model now, and the model stop time we will put as 9 o'clock. So and the day as 21st of same day. So when I reset it and I run it, we should have 40 parts and the model should stop. So I'll make it at full speed and say you are having 38 parts. Now if I put it to 10, so you see for 8 to 9 it's 40, and for 9 to 10 it's 60. So 38 plus 60 parts we should have. So I am again running it. So it's approximately 100 parts we need to have. 60 plus 40, so it's 103. So you can see this is all about hourly. Now the deviation we have seen here is like, now if we wanted 100 parts but it's 103, we wanted 40 parts but it came about 38 parts. The reason was because of this interval variability. This variability we can change it to constant rate, we can change it to exponential, change it to normal, and change it to log normal depending on our need, and put the standard deviation accordingly. That's the reason we are having the deviation in the original value. If we go at the constant rate, there is no standard deviation, so it will come with a 40 and 60 respectively. So we can check it once with the constant rate. We'll make it 9, we'll make it reset, and we'll make it run. So it's 40, we'll make it 10. This part has not come because it's exactly 9. If we put it 901, it should come. So see, we have 40 parts when we changed 1 minute ahead of 9. Now for 10 we need to have 40 plus 60, 100 parts. So we'll change it to 10 o'clock the same day. We'll reset it, we'll run it, and we have 100 parts. the one is extra. So this way we are having the weekly repeating thing with the constant rate. We can go with exponential normal or log normal method. So this is all about the periodic rates repeating weekly. Then we have hourly rates, custom daily repeat. So this is like every day same pattern will be repeated irrespective of the week and all. So here also we need to put same. Depending on the timings, number of parts required, we need to enter that part quantity value here, and we need to select the interval variability. Depending on that, we will have the throughput coming out here from the source. Then we will go with daily rates. Now this is daily rate weekly repeat. So here similarly on Tuesday, this comes basically on a whole day, how much output you want on that particular week, and then that takes place on a weekly repeat basis. So we'll try one. So what we'll do is, for a Thursday, we will put say 209 parts, and we will bake this to till 12 o'clock. (24, 23, 59). We have changed the start time, so it is from the first minute starting of the Thursday, and it's 1 minute lesser to 12 p.m. of Thursday. So we have considered 24 hours of Thursday. So if you are going to reset and run this model, we are going to get output of 208 or 209. So if you see, it's 208, and the deviation of one part is just because of 1 minute lesser here and 1 minute. So this deviation, otherwise it will come to 209 with the exact timings. So this is related to our third option in the periodic rates. Then another option comes is by time of the day. By time of the day is the method where we need to enter the interval time in certain hours. So if you enter 20 as a number for that hour, every 20 second or minute, as per our model unit, the parts will be produced. So for example, at 8 a.m. if you are going to put as 20, and our model units are in minutes. So if we check the model units, it is in minutes. That means the time will be applied is in minutes. So for 8th hour, where we have 60 minutes in an hour, every 20 minutes we will have part coming out. So we'll check that out now. So we have set the timings from 8 a.m. to 9 a.m. to check whether our rule is going to run perfectly. So we have entered by time of the day, that is 20 parts at 8 to 9 and 9 to 10, 20 parts. So we'll check first 8 to 9. So 8 to 9 we need to have 3 parts, because we have 60 minutes in an hour, and every 20 minutes we are going to have a part. So we are going to have 3 parts coming out. So if you reset and run, if you see this, we are having 3 parts coming out. So we have successfully validated by time of the day method. So this way by time of the day method works. Then we have batch processing. Now batch processing is, we can create parts into the batches from the source. So as per requirement of the project or tutorial or case study, we can apply any of the rule for inter-arrival time. So we'll understand what is batch time now. So based on batch size, we are going to assign a cycle time. For cycle time, we can apply standard distributions. We have this number of lists for here. We can apply a cycle time from the global table, as we have seen by global table lookup, or we can apply the cycle time based on the label value. So we will see a plain cycle time entry method. So we'll just enter 10 minutes. So the label will be assigned to that batch accordingly. So it will come on the source. If we are going to reset it, the label will come on the source, which will state that the source is going to produce the parts based on batch processing. So if you see, we are going to produce parts in a batch size of 5 and in an interval of 10 as a cycle time. So in an hour we are going to have 6 parts, that is we are going to have batches of 6, that is 6 5 is 30 parts we need to come out. So 30 parts need to come out in an hour as per this batch production we have applied here. So you can see we are having 30 as output. After we have seen batch processing, we will see now different time for nth item. The process flow executes a flow rule we will see when we are exploring process flow. Currently we will go with the conventional methods. So all conventional tools we will be looking first. So we will be directly going to the different time for nth item. So this is the another rule which is available in the inter-arrival time, where we can put the item, we can put the time for the nth item, this is cycle time, and time for others. So what does this state is that the fifth part which is going to come out from a generator will have a cycle time of 10, and all other parts will have a cycle time which we are going to mention here in the tab, that's 2 minutes. So basically this rule is applied only to apply a cycle time based on the part number. So it's like nth item, if we want to assign a cycle time, and rest of all other items we need to assign different cycle time, then we are going to use this. So here we are going to have the options to enter the labels, or we can fetch the values from the global table. Similarly it goes for all 3 tabs. So what will happen now is, for the fifth item the cycle time of 10 minutes will be applied, and the rest all we will have as 2. So we'll reset and we'll run and check. So we know that the fifth item should have a cycle time of 10. So this is timestamp of, so this is the first item, second, third, fourth and fifth. So if you see, the timestamp is 18. For fourth it's 8. So you can see that the difference of the cycle time is 10 minutes. So the fifth is produced after 10 minutes when fourth item is done. So this is that rule, different time for nth item. This way we have completed all the rules into the inter-arrival time, and now we need to look into the another tab, that is output. So we have seen statistics, we have seen high level template, then we have seen visuals, labels, source. In source we have seen these 3 rules, and now we will be looking into output. In output we are going to have these number of rules applied in this tab. We will see this one by one. So this is the list of the outputs where source can send the part. So we have first available, we have by expression, we have queue size, random, round robin, and all these options. We'll see these options step by step. So this is first option, first available. So this says that, say when the source is connected to multiple options, we are going to change it. Say the queue sends the part to this top queue which is %40 and the bottom queue which is %60, then where should it send the part? So this is the strategy where we are going to apply it, send to port. So the first available strategy says that the part from the source will be sent to the queue based on available basis. So whichever queue is available first, the part will be sent to that queue. Now first available means what? So say for example the queue capacity is 10 and the below capacity of queue is also 10, but this queue has full capacity of 10, this also has a capacity full of 10. Now say this queue one part is taken away, so now the capacity of the queue is 9, but this queue still has the capacity of 10. So this queue is now first available, so the source will send the part to that port, to that queue. This is known as the first available strategy transfer. It is the most simplest and easiest. Then comes buy expression. Buy expression is the strategy where the part is sent to the port number based on the item level. So for example, if we are going to produce two types of items, say item 1 and item 2, and if the item 1 is generated, then it will be sent to port 1, and if the item 2 is generated, then the item will be sent to port 2. This send to port we will be using frequently in all our model building techniques, so we will see those in future. Then comes queue size. So the queue size is basically depending on the capacity of the queue, so content of the queue. Say this queue, the top queue has parts count as 10 and the bottom queue has the part count of 20, then this queue is the shortest queue and this queue is the longest queue. So this is based on the queue size. So shortest queue, if applicable, it will put that part on the shortest queue, or else it will put on the longest queue. This is that strategy. And the longest queue is, if the longest queue is available, it will put the longest queue, or else it can also put the shortest queue. But if we are going to select this strategy, this shortest queue, it will always put the part on the shortest queue, even if you are having the longest queue available. So we need to use this shortest queue if available. So if the shortest queue is available, the part will be sent to the shortest queue. If it is not available, it will be sending it to the longest queue. So this is based on the queue size strategy. Then comes the random. The word random itself states that the part will be sent it to the random port. Now, as we are understanding what is port, so we are having three types of ports in the Flexsim software. So the port which I have connected this is the type of A connection. So you can see this is that connection. So A connection is input output port. Then we have another connection which is Q connection, that is center port connection. So we have majorly three ports. One would be output port, one will be input port, and another would be center connected port. So input port, output port, and center port. So input output port is done by A connections. So we establish it by A connection. Why it is A connection? On the keyboard it's shortcut key. We need to keep A button pressed and hold it, and then click the left mouse button, drag it to and release it on the object you need to create a connection. So this is the output connection we have created. If we are going to drag A from this queue, that is %60 queue, to the queue 1, then the direction of this will be in this way. So the part will go from this queue to this queue. So for percentage it's output queue, and this direction connection is the output queue for Q1. Then we have center connection. The center connection is applied for the task executors in order to use them as for executing the task. So this is the operator, and if you want to create a center connection, then we need to press and hold the S key on the keyboard. Then we need to press and hold the left key on the queue, and then we need to release it on the operator. So the center connection is established between this queue and the operator. Then if you want to connect this %40 queue, we need to press and hold S key on the keyboard, then click on the queue, left click on the queue, and then again left click on the operator. You will have this center port connection established. So this is center connection porting, input porting, output porting, which we did. Now we will again come back to our send to port strategies. So we are using these strategies for sending parts out. So for output port, these strategies are applied. So we have seen what is first available expression, queue size, random. In random, the word itself says it is a random porting. So you can send to the random port, you can say to the random port available. Say if the random ports are not available, then it will again send to the random port only. What does it mean? Say the random port has decided to send the part to the %40 queue, but the queue is full. So the source will wait until this is freed and then send it. So if you are going to use the random available port, then it will check whether this is available. If it is not, then it will run another random loop and it will find another queue and it will send the part to that. So it will not stop and wait. So this is the random. Then we also have by percentage. So you see here, we can put that the 60% of the part should go to the port 1 and 40% part should go to the port 2. So this port 1 and port 2, you will get it from this port. So if you go to the output port, you can see that first port is connected to the 40 queue, then second port is connected to the %60 queue, and third port we have again connected to the 40 queue. So what we state here in the random port by percentage, if you state this way, 60% should go to the 1 and 40% should go to second port. Then you can see one port means it will go to the queue %40 and port 2 means it will go to the %60 queue. This is sent to port by percentage. Then we have round robin if applicable. So round robin if applicable, this means this is most probably used. So we'll see one example. So round robin is, it will send part to in an alternate way. So it will send the part to %40, then it will send the part to %60, then again 40, 60, 40, 60. This way it will send the part. So if we run the part, so if you check, we have applied it round robin and the interval of the time we have set as 10. So after 10 minutes you will have the part coming on the another queue, then again it will go to this queue. So this is round robin method, you can see it. Now in the round robin there is another option, round robin if applicable. Now say this queue has the capacity only of this is 1000 we have. So if it is only having say 2 capacity, this has 1000. Now round robin can be applicable only till 2 parts. After that round robin cannot be applied because only we have is 1 queue left. So if we reset and run, now for first 2 loops it will do, then it will send the parts on this queue itself. But if you see, this is the strategy for if applicable, all if applicables which we have seen, and the queue size if applicable. So round robin, if you put only round robin, so the source will go on blockage after 2 parts are sent. See, the third part it will not send because the strategy we have selected is round robin and the source will go into the blocked state. So what does that mean is, the round robin if applicable is the strategy used. If round robin is not going to get executed, then what? Then we need to use this strategy. If it is applicable, use it. If not, then go with available basis. So this is round robin strategy if applicable. Then we have use list. We will see this strategy when we are going to have a detailed session on lists. Then we will go to by port case. Now by port case is similar to the value by case strategy which we have seen for inter arrival time. What we'll do is, based on the label name, it will assign the generation time at the source. For case 1, if the part type is 1, it will assign 5 minutes, which we seen in the previous example, and for part type 2, it will assign 10 minutes. So this way, what here it will do is part by case. If the item type is 1, it will send to the port 1. If the item type is 2, it will send to the port 2. If the item type is 3, which is not present here, that means it is a default, so it will go to the port 1. So that option we can put depending on our requirement. So this is the strategy, port by case. Then we have conditional by port. So the name itself defines that it is depending on the condition. Conditional port means. So conditional port means depending on the label we are going to suffice, it will send to the ports. So if it's true, it will send to the port 1. If it is false, it will send to the port 2. So this is for 2 ports. We can add it up in this scripter, that is code editor. We can add this more. So if the item type is 1, it will go to 1. If it is 2, it will go to 2. If it is 3, it will go to 3. If it is 4, it will go to 4. We can put that in this code editor platform, which is situated here. And this is the simplest form where we can utilize it by just changing the values here, and we can have the conditions sufficed. If you want to go in more detail, we can go in the code editor. So this is conditional by port. Depending on the item type, it will send to the respective port. So if it is true, condition is true, it will go to 1, or else it will go to condition number 2, that is port number 2. Then we have by global table lookup. Now this is similar. What we are going to do is we are going to fetch the value from the global table, similar to what we saw in the time. Instead of time we enter here in the cell, we are going to enter the port. So 1 or 2 or 3, depending on whatever port we are going to require. So we are going to select the row, we are going to select the column, we are going to select the table, and we are going to get the value from that table for the port. So we'll just try one scenario where generation, we'll put this as 1, we'll put this as 1. So if you see, we have this as port 1. So the parts will only go to the port 1, that is %40. So if I reset and run, it should go only to this queue. But as we have set the capacity to 2, the source will go into blockage here. It has not sent a single part to another queue. So it has taken the value from the table. So this is global table lookup. Then we have matching item labels. So it depends on the label. So we are going to match the label. So the label on the part which is going to get generated from the source has a value 1, and the label on the queue, say %60, the part at this queue also has the label value as 1. Then this part would be sent to this queue. If the part label from the source has the value 2 and the %40 queue has the part with the label value of 2, then the source will automatically send the part to that queue. So this is depending on matching item labels. So we are going to send it based on matching the item labels. So the item label placed on the sending object and the item label present on the delivery object. Then we have by time of the day, and then we have do not release item. So do not release item is basically related to we are not going to send the item. So it's basically blocked state. We are not going to send a single item out. So if you reset and run, you will see even if we are, the model itself will not run because this our source itself we have kept as blocked, that is no item release. So this is the all about output. Use transport, this is the condition we are going to use to assign an operator, assign an forklift or AGV to transfer the material from one location to another location. So we will see this in detail when we are going to use queue processors. There we are going to assign an operator for transferring the material. Then we have priorities and preemptions. Preemptions is priority is the word itself states that the operator needs to assign the priority. So if the same operator is taking care of this queue and this queue for material transfer, I can assign in the queue the priority as 1 and then here priority as 2. So this is what the priority means. So the operator will always check for the part available on this queue and lift it off. If not available, it will go to the another queue. So this is the priority thing. So, and the preemption, here we are having number of preemptions. These are the conditions or the rule applied. Preempt only, preempt and abort active, preempt and abort all. So this we will see in detail again when we are going to use queue processors, because there we are going to have it used. For source, it's not that useful. Then we have another tab known as ports. Here we can see number of ports. What are the input ports for the object? What are the central ports for the object? What are the output ports for the object? You can see from here. So this is like you can add the ports here from this plus symbol. This is a sampler. You can select here from the sampler which port you want for output and input. Rather than creating a connection, you can also pull it from a sampler here and it will get added up here. This is the delete button. This is for sending the ports upward and downwards. These are required, very important when we are going to use combiners or sequencing. This sequence of ports is important at the time. And this is a binoculars where you can find the object in the queue. So this way, if you are not getting the object when we have a very large models, you can use this feature to identify where is the object present in the model. So this is all about ports. Then we have another thing that is named as triggers. So these are the lists of the triggers. So triggers is where we are going to apply a code, where we are going to apply a logic which will be executed after certain state. That is, whenever a part exits from the source, whenever part is getting created, on draw trigger is based on the movements of the cursor. So it is based on the layout. This we will understand in detail. This is a very big concept. Then we have on reset. Then we have on message. On reset means whenever a model is resetted, that code will be getting executed. On messages, whenever a message is sent, so we need to send message first, then this trigger will be executed. And we can send the message by writing a code inside the matrix. So for example, on exit, if you see on exit, we have put it them if you want to send. So here are again a long list of items which we need to do. On exit, we can put the data controlling, set label color. For controls, we can put expressions, close open board, list, visuals. There are a lot of things. Here itself there is an option where you can send message. So when you are going to send the message to something, you are going to read that message. So this is another trigger on message. Then we have on stop, pick offset, on resume, on state change. So in source, we are not majorly using these triggers. We majorly use triggers from this queue to basic FR. So we will see all these things in detail in those tabs. So the most major importance of the tab for the source is this, that is source generation, because rest all the tabs we are having it in all other fixed resources, and we mostly use them in another fixed resources. So we will see them in detail when we are studying queue, processors, combiners, separators in detail. Thank you for watching, and this is the end of part 2 for the source. If you have any queries, please write down into the comment section and we will try to address it. Thank you.